we've got our slope formula, which is change in y over change in x. We've got our distance formula, and we've got our midpoint formula. All of these for two-dimensional figures, or things on our coordinate plane with some x and some y value. Okay, example 1 says that if xy is a mid-segment, which is a segment that connects two midpoints, what are the possible coordinates? Okay, so xy could be any of these, right? All of those are connecting our 2 points. So we're going to have to do it for each one. So if I'm going to find the midpoint, let's start with from A to B. Okay? So where is the point A at? What's its coordinate point? Okay. All right, and where is point B at? Good. All right, so those are going to be the points that we're plugging into our formula, right? Okay, so we're finding our point, that's this formula right here. Okay, so it should be x2 plus x1. What's our x2? 4. Plus, what's our x1? Good. Over 2. And then same for y. What's our y2? Plus, what's y1? Good. Over 2. Okay, and then we just need to simplify. So what is 4 plus negative 4? 0. And what's 0 divided by 2? Good. Okay, and then on this one, 6 plus 2 would be 8, and 8 divided by 2 would be 4. Okay, so the midpoint between these two is at 0, 4. So that could be the end of xy, since it's supposed to land on a midpoint. Right? Okay? It also could have been between the points B and C. Okay, so we already wrote down the coordinate point for B. Where is our coordinate point of C? Good. So now this is our x1, y1. This is our x2, y2. Okay, so same formula. What is our x2 plus x1? Good. All right. And then y2 plus y1 would be 0 plus 6, over 2. And then we just simplify. So what is 7 plus 4? 11. And what's 11 divided by 2? Good. And what is 0 plus 6? 6. And 6 divided by 2 is 3. Very good. Okay. It also could have fallen between points C and D. So now we're going to find the midpoint between C and D. So we got our point C. Where is coordinate point D at? Okay. All right, so x2 plus x1. Very good. Over 2. And then y2 plus y1 would be divided by 2. All right, what is negative 1 plus 7? 6. What's 6 divided by 2? Good. Negative 4 plus 0? Negative 4 divided by 2? Good. All right, and then the last possible option could have been that it was the mid-segment between D and A. So from D to A, okay, so D is x1, y1, A is x2, y2. So x2 plus x1 would be over 2, good. And then y2 plus y1? 2 plus negative 4, good. Divided by 2. All right. What is negative 4 plus negative 1? Negative 5, and negative 5 divided by 2 is good. And 2 plus negative 4? Negative 2, and negative 2 divided by 2. So, any of these coordinate points could have been the midpoint that xy was. Okay? Alright. Example 2 says to determine if the quadrilateral on this grid below is a rectangle. Okay, so this one's going to require a couple things. First, we got to think, what do we know about the sides in a rectangle? The sides. Right. The 2 on the ends are equal, and the 2 on top and bottom. So opposite sides are going to have to be equal if this is a rectangle, right? Okay, so opposite sides are congruent. Okay? Well, our sides are going from one point to the next, right? What formula would I use to figure out how far it is from one point to the next? Right. So we're going to have to use our distance formula for each side. Okay? So, point A, where is point A? 0, 1. Where's point B? Good. And C? And point D. Alright. Okay, so those are the points that we'll be using in the distance formula. Okay, so first we're going to find the distance from side A to side B. Okay, so our distance formula is the square root of x2 minus x1, which would be, those are y values. So we need 7 minus 0 squared, good, plus, good, squared. Alright, and then we simplify. So what is 7 minus 0? 7, and what's 7 squared? Okay. Alright, and what's negative 3 plus 1, or minus 1? Negative 4, and what's negative 4 squared? 16. Okay, and what is 49 plus 16? 65. Very good. Okay. Now we got to find our side from point B to point C. Okay, so we got x2 minus x1. What's that going to be this time? Good. Good. Plus y2 minus y1 squared, which would be good. And then we got to simplify. So what is 3 minus 7? Negative 4. And what's negative 4 squared? Positive 16. Alright, and then negative 9 plus 3? Negative 6, and negative 6 squared is good. And what do we get when we add those? 52. Good. Okay. Alright, and now we're looking for side CD. So which side should CD be congruent?
Or A.
Yes, the AB side. Right, very good. Okay, so we're hoping that those are the same so that this can be a rectangle. Alright, so under my square root, x2 minus x1 will be plus y2 minus y1. Good. Okay, and what is negative 4 minus 3? Negative 7, and negative 7 squared is? Okay, and what is negative 5 plus 9? 4. What's 4 squared? So when I add them, we get... Okay, so are the two opposite sides congruent so far? Okay, now we just got to make sure that BC and DA also follow that rule. Alright, so side DA. X2 minus X1, what's it going to be? Plus 4, very good. Plus, good. And 0 plus 4 squared is 16. And 1 plus 5 squared is, so that side is, okay. Alright, so far so good. The opposite sides are congruent, so we checked that idea off. But somebody also said something about the angles. What did those have to be? 90 degrees. Okay, so angles are 90 degrees. Okay, so now we got to figure out if those are intersecting at a 90-degree angle. Well, we know what kind of lines intersect at a 90-degree angle. Perpendicular. So if we can prove that their slopes are opposite, right, or perpendicular, then we should be able to prove this. Okay? So this means we're going to have to use slope formula. Okay? All right. So let's first do this for over change in x. We'll do this for side or for line AB first. Okay. All right. So our slope formula is y2 minus y1. What's that going to be for AB? Good. Over x2 minus x1, which would be, okay, and negative 3 minus 1 is, and 7 minus 0 is 7. Okay? Alright, now I'm going to do the same thing. So this side was AB, then that means side BC should be the opposite if they're going to meet at a 90-degree angle, right? So now we're going to check the change in y over change in x for side BC. Okay, so our y2 minus y1 would be what for that? Good, or plus 3, right? Over x2 minus x1, which is good. All right, what is negative 9 plus 3? Negative 6. And what is 3 minus 7? Negative 4, which would simplify to 3 over 2. So are my slopes reciprocals and opposite sides? No. So is this a rectangle? No. Okay, so although the opposite sides were congruent, the angles were not right angles, therefore this is not a rectangle. So it was some type of quadrilateral, just not necessarily a rectangle. Okay, flip it over onto the back. It says On a coordinate grid, line M passes through the points 3, 2, and 3, 0. So I'm going to put those points down here. 3, 2, and 3, 0. Okay? So if they go through those 2 points, it must be a vertical line, right? So here's our line M. Okay? And then it says that line L contains the points 6, 14, which won't quite fit on this line, and negative 2, 14, which again won't quite fit on this line. However, if they have the same y value, that one's going to be a, what kind of line? Horizontal line, right? Okay. So it must run this direction because the y value isn't changing anymore. So at, what was it, 6, so that would have been here, and then 14 would have been somewhere up here, and negative 2, 14 would have been somewhere up here, right? It kind of goes off our graph, but it's going to have to run this way because the y values didn't change, okay? All right, so they say which of the following is true about line M and line L. Okay, so F says that these lines are parallel. No, because eventually these 2 lines will cross or intersect. Okay. All right, G says that they are perpendicular. They could be, right? Because a vertical line and a horizontal line, those are going to meet at what kind of angles? Okay, so that could be it. Okay. All right, and then H says that line M has 0 slope and line L has an undefined slope. Okay, so let's think about that. Our slope is rise over run. Okay. Okay, the first line we drew, line M, it's rising, right? It's going up. At some point, what was it? It went up by 2. But did it go left to right and did it run? No. And can you have 0 in the bottom of a fraction? No. So this one is undefined. While line L did not rise, but it did run, moved by 8 points, right? And what is 0 divided by 8? 0. Okay, so that said line M has 0 slope and L is undefined. Is that true? Yeah, it would have been opposite. And J is none of the above. So which one was it? G.